Okay, Chapter 5, Section 1. We're going to classify polynomials and describe graphs of polynomials. I thought this was really funny last night when I made the notes. What math concept is this? Polynomial. Okay, so the first thing we're going to do is rewrite the polynomial into standard form. So standard form, we start with the largest x term and then just go down from there. So what's our largest x term that we have here? Well, we're looking at like the x squared part. So 9x squared would be our biggest x term. So we have 9x squared that we're going to write first. Then since we have x squared first, the one right down from that would just be x all by itself. So then we would just do plus 3x. And then the last one we have is just the constant 5. So we're just rewriting it in standard form. Let's go to the next example. Yeah. What is our largest x term we have here? X to the fourth. So we're looking at like the x and the power above it. So x to the fourth would be the largest one. Do we have any x to the thirds? No. How about x squared? X to the second. We have 10x to the second. We also have this x squared too, right?
Yeah, but that's negative, so it's after it.
We combine them. So if we have two terms that are the same, so we have an x squared and an x squared, we need to combine them. So we combine the like terms. So how would we combine negative 6x squared plus 10x squared? So it would be plus 4x squared. Do we have any x's all by itself?
Yeah,
the 4x, so we write 4x next. And then any constants? Minus 12. And that's our answer.
Oh, so you don't have to solve it?
Nope, we're just rewriting it. Okay, and one more example. What is our largest m term here? Remember, we're looking at the m and the power above it. So 2m squared would be the largest. And then we just need an m all by itself. So do we have any m all by itself? What would it be? So plus 7m. And then what comes last? Minus 3. So we're just rewriting it in like descending order. So we need to start with the biggest term. So here 2 is our biggest power of m. So we need to start with that. So we're not even looking at the numbers that come in front of the variables. We're just looking at the powers. Okay, next we're going to classify polynomials by degree. So the degree meaning the power. So if we have x to the 4, this is the degree. So when we don't have any x at all, our degree is 0, and we have a constant number. So when there's no x's at all, our degree is 0, and we have a constant number. If we have an x with no power above it, but we have that x, it would be like x to the power of 1, so our degree would be 1. And we would name this as linear. If we have an x squared, our degree would be 2, and it would be a quadratic. If we have an x cubed, our power is 3, and it's cubic. x4, it would be quartic. And x to the 5th would be quintic. Okay, so we need to classify the polynomial by the degree. So we need to look for the highest degree we have and classify it by that. So what's our highest degree here? X. And just x all by itself, what would the degree be here? But what's the number? 1. So our degree is 1. And what would it be called? Linear. What's our highest degree we have here?
Could you go back up to the last one really quick?
Yeah. So our highest degree is x to the 4. Our degree is 4. And what would a polynomial with the degree 4 be called? Quartic. So we can really just ignore everything else because we're just looking at the highest degree. What's the highest degree we have here? P squared. So this has a degree of what? A degree of 2. And what would something with the degree of 2 be called? Quadratic. Okay, so next we're going to classify polynomials by the number of terms we have. So if we just have a number all by itself, there's only one term here. So the number of terms would be 1, and it would be called a mononomial. In our next example, we have 2 terms. We can't combine x and 4x, so we just have 2 terms here. So our number of terms would be 2, and if there's 2 terms, it's called a binomial. In the next example, we only have 1 term, so again, it's just a mononomial. In the 4th example, we have 3 terms. We can't combine any of these, so it's a trinomial. And in the last one, we have 4 terms that we can't combine, and it's just a polynomial of 4 terms. So there's only names for 1, 2, and 3, but anything above that, you would just call it a polynomial of however many terms it has. So we're looking at, let's look at this one. We're looking at this term. So this is 1 term, this is another term, and this is another. So the number in front of it doesn't really matter. Like this, we have 1 term, and we have nothing added to it. Yeah. Okay, we'll do some examples. Classify the polynomial by the number of terms. How many terms do we have here? We have 3, right? 1, 2, 3. So 3 terms, and it would be a trinomial. What would we do for this one? We need to combine the like terms first. So we add 7x plus 3x, and that would give us 10x plus 5. So now how many terms do we have here? 2. We have 1, 2. So if we have 2 terms, what would it be called? A binomial. What about here? Classify the polynomial by the number of terms. How many terms do we have here? 1. So when we have one term, what would it be called? A mononomial. Okay, the last thing we're going to learn today is the end behavior of a polynomial function with the leading term a of x to the n. So the a is going to be like the number in front of it. So the a term is the number that's in front of the x variable. If it's positive and the n is even, so x is raised to an even power, then our graph, the end behavior of our graph will be up and up. So if we look at the first one, y is equal to x to the 4th, our number in front of x, it's 1, so it's positive, and x is raised to an even number. So the number in front would be 1, and it is positive, and this 4 is even. So if we have a positive and even, our end behavior of the graph is going to be up and up. So our graph end behaviors will look like this, up and up. So if we had like an x squared graph, we know x squared, when the number in front of x is positive, it looks like this. So in x to the 4th graph, the end behaviors of the graph are going to be the same, but the graph in the middle here will be different, but we're just focusing on the end behaviors.
Wait, how do you determine, like, when the arrow is going to the 4 and it says even?
So we're looking at like the highest term in our polynomial, and that'll give us the end behavior. So the degree of our highest term is 4, and 4 is an even number.
Oh.
You'll have to describe the end behavior, so this is all you'll have to graph. So you don't even have to graph. You could write the words up and up, or you could just write 2 arrows going up. So next we have if a is positive and n is odd. So this one, the number in front is positive, and 3 is an odd number. So our end behavior of the graph is going to be down and then up. So the graph of y is equal to x cubed looks like this. So any polynomial that has an odd exponent, the end behaviors are going to have these same behaviors. So they're going to go down at first, and then it'll end going up. Okay, next we have when a is negative and n is even. So we have a negative 14, negative, and an even number. Our graph is going to be down and down. So we know that if we had a negative x squared graph, it would be a frowny face. So a graph that has x to the 6th power will look something like this, but it'll have that same end behavior. So the graph will be pointing down and down.
It would look like an M?
I'm just saying, like, we don't know what this part in the middle would be, but we do know what the end behavior is going to be. Okay, and the last one, when a is negative and n is odd, so we have a negative 7. and our degree is odd, our graph is going to go up and then down. So it's just going to be the reverse of the x cubed. So if we had a negative x cubed, it would be that same thing as the green, but it would just be flipped. So it would look like this. So it starts going up and ends going down. Okay, we have a couple more examples. So it says, classify the end behavior of the graph of the polynomial. So we're looking at the largest term. We can ignore the rest of it. Is the number in front of our largest term positive?
Yeah.
Okay, so 9 is positive. And is our degree even? Yes, it's even. So if you go back to the page before, what did we say that a positive even term, the end behaviors are going to be? Up and up.
Wait, so that's the answer?
That's the answer.
So you don't have to like simplify anything?
Nope. I always think of it as like x squared is a smiley face. So since 2 is even, if it's our degree is even, it's going to be up and up. That's just the easiest way to think of it, is just as x squared. We know what the x squared graph is, so if we have an even number, it's going to look, our end behavior is going to look just like that.
And so the reason we didn't do negative 17 x to the 7 powers because
We
9.
only look at the highest degree. So since 10 is our highest degree, we can ignore the rest of it. Okay, last example. What term are we going to look at here?
The big one.
Negative 9x to the 8. So is 9 positive? Is negative 9 positive or negative? Negative. And is 8 even or odd? Even. So if it's even, they're going to have the same behavior. So it'll be up and up or down or down. So what do you think this one's going to be? Down and down. Because that 9 is negative, it's going to be down and down. So you could just think, we know our negative x squared graph is a sad face, and it has the end behaviors of down and down. So our negative 9x to the 8 is going to have that same end behavior, just because it's also even.
What if it was like a 7 instead of an 8? Would it be odd?
So if we had, let's say, 8x to the 7. So 8 is what? Positive or negative?
Positive.
8 is positive. And is 7 even or odd?
Odd.
Odd. So when it's odd, our end behaviors are going to be different. Do we start going up or start going down? Go back to the page, 2 pages before with all the... So if we have a positive, odd...
Oh, down.
Down and up.
So it goes down and then up. So just think, if it's positive, it's always going to end going up. It ends on a positive note, going up. And if it's odd, the end behaviors are different. So it's not going to be down and down or up and up. It'll be, one's going to be going down and one's going to be going up. Okay, I know this was a lot, but let's go over the first couple questions of the homework.